Hello, everyone. I'm Renato Nascimento, Head of Technology of Articul8. And today we'll peek under the hood of Articul8's platform architecture and understand what it takes to build and run hundreds and thousands of domain-specific and task-specific models and agents. So there are many solutions out there, and it's a known phenomenon that's not that hard to build a cool demo or a POC that you can run on your laptop and show some cool demos. But also very common, which is they all fall short when you need to bring that in to run hundreds or thousands of concurrent flows, bring to production. Usually that's when they fall flat. It takes a whole platform that was designed and built for that, so you can achieve that in production. So we built that platform that can run on the customer premises, either that be on a cloud provider, on all the major ones, or on their own on-premises, that being even air-gapped, right? No need to access external call to the internet. That architecture is centralized on a Kubernetes, right? That allows us to build resiliency on the system, where every component of the architecture is isolated and can elastically scale. For instance, we have our API service layer, where those are stately pods that can scale horizontally and are high available, and then can route requests as you're receiving that. And this, it means few requests or hundreds of thousands that allow the platform to scale. On the same token, we also have our model mesh orchestrator. That's where the intelligence of the platform is, where it allows you to smartly run dynamic autonomous flows. And that was the challenge when we were building this platform. There is no available out-of-the-shelf solution out there that can do low latency, real-time, dynamic execution. There are many solutions that check some of those boxes, but very few, or we couldn't find one that run in production that achieve all of that. And that's why we built our own. And then that allows, that intelligence layer allows you also to dynamically and smartly route between many models that you have deployed on the platform as well. As you guys seen so far, we deploy internally on this self-contained platform dozens of models. And at the runtime, you need to be able to execute and run flows between those models in a smart way, right? And on the bottom of the platform here, we have the intelligence layer where we persist and keep all the information important for enterprises. Like you have observability, and very important for auditability, very important for enterprises, compliance, and also SOC 2 resilience as well. All of that, we try to provide that to our customers in a very easy way with our interface, with our CLI, that their IT team can just come and run on their cloud provider that will provision everything. You don't need experts on your side to do that. It helps if you have them, but that's not required. And that can also, because it's based on Kubernetes, can also be run in on-premises as well. What it takes to build domain-specific and task-specific models and run them at scale, right? Building the models itself is really just 10% of the effort. We know that it can be expensive depending on the size of the model, but the intellectual effort and the actual creating the model, it relies on, do you have the right data for it? So much aspect of it, it goes into our autonomous data creation, where we have the knowledge graph, which we're gonna show on a live demo in a second, which is builds augmentation of your data. So you have your data, and then we create information on top of it. That information, it creates on top of it knowledge, which is unforeseen connections between your data. That's very important. It helps you to build those domain-specific and task-specific models. And then you need to understand what is the right architecture for that specific use case as well. And then be able to autonomously deploy those models on our model mesh and make sure that they actually achieving good results for that specific task. So all of that needs to be orchestrated on a platform. And it takes a lot of effort to make that run in production.
And Renato, is the data, the knowledge graph generation, updating, is that part of this model mesh, or is that some other?
It is. So when you are ingesting data, you don't need to say anything about your data. That data goes to our intelligent model mesh layer. It will break that apart and understand, hey, this is an image. It is a chart, not a picture. So I do need to go to the chart task-specific model to understand that. Or this image is actually a table, and I'll show in the demo what happens. No, so that now it's a table. I now only need to do OCR, but I also need to do table understanding on this. I need to do summary statistics. I need to understand what this table is about. All of that happened during ingestions without the user provide more data about that. And that's a key component of building a model. Because if you just drop the data, we talked about domain-specific data with public available data on domain-specific. You go to a publisher like our partner, Epri, right? They will have the papers. They will have those PDFs. But how you understand specifics about those papers, it's really important how good your model gets, right? That's 90% of the effort that goes in building those models. And questions about model size, right? There is also a common misconception that domain-specific models are all tiny or small models. Not the case, right? Model size depends on model capabilities. That depends on the task complexity, right? As you can see here on the bottom left on the plot, vertical axis is model size, and on the horizontal plane, we have data size and task complexity. On the bottom left of it, or a use case, you have very little data, and the text is very complex. You might actually require a model with significant size. For instance, you're doing a manufacturing analysis of a sensor data that is sparse data. You might have very little data, but you still need a model that can understand and comprehend that what that information is about. So you might need a very large model to understand that. On the other side, if you look where you have a lot of data, but your task complexity is not that high. For instance, I want just to categorize a bunch of support tickets that I have. Then even if you have thousands and thousands of documents, you can still do with a smaller model that can achieve that categorization. So that's key to understand, and we play a role in all the spectrum. We have dozens of models. They go all the way to be on the large side, and have dozens of models that go to the more smaller specialized sizes as well. Now that we talk about what is under the hood, what is important, I actually want us to focus and see it running live as well. So I'm gonna switch my screen here to our platform. Give me 1 second. There we go. And the first thing I'm going to show, I hope everyone can see this clearly, is a visualization of our knowledge graph. And it's really important to understand that's the visualization, right? This data set is about aerospace engineering in general. As you can see here on the left, I'm gonna go through. We have 6.3 million entities on this graph. So this is not a simple example. There's a lot of data here that came from 200,000 pages. So tons of data to generate this knowledge graph. Our system automatically detects 160,000 topics. This is not given by the user. We understood what was the topic of that documents, and we also create hierarchical clusters connecting them. We're gonna, that's what you're seeing on the visualization. And 800,000 images and 130,000 tables. Why this is important? And then this visualization, we call internally the shape of data. It is a dimensionally reduction. So the axes actually mean how the data is close or far apart of each other. So the clusters here on that corner here for instance, rock proportion and combustion analysis, are further apart from the other corner of the cluster that talks about something else, like, for instance, altitude and orbit control techniques. All of that automatically done by the platform. You don't have to opinionate anything. You just drop the files here. How is that important? That allows you and the platform at any time tap into this knowledge, either if you're building a domain-specific or task-specific model like we do, but also if you're running this live and you want to understand some connection between data. And I'll show an example of what we talk about here. So I'll do a live search here. All right. So you see how fast that search was? This is running live. We are not mocking anything here. That shows where that search is correlated on the graph. So where in the semantics position that is. And it's bringing that together for you all across those 6 million entities. The reason that I like that query is it identified a table image, right? So this was an image that was inside a paper. We not only identified that image as a table, but understood that table. So this was the generated content that our platform with the table specific model could do. So it is explaining what the table is about. So it's not only doing OCR, obviously we do the OCR, we have the actual content as well, but also what that content is about. That augments the data, and that gives opportunity to connect this with other similar information you have on the knowledge graph as well. Very, very, very important. So explaining all of the data besides just doing LCR with a table expert model.
And to be clear, this is really just the knowledge graph segment of your solution. This is not the domain-specific models behind aerospace or space or anything like this.
No, they can be used to generate that information.
Hello everyone, I'm Arun Subramaniyan. I'm the founder and CEO of Articul8's. I wanted to augment the discussion here. So one thing to first notice, he searched for escape velocity. The table doesn't have escape velocity anywhere on it. It doesn't even have the term velocity anywhere on it. Number one. So if you go search for any of these things,
V, and
yeah,
there are some indicators of velocity on the table, yes.
That's a V on an image, though.
On an image.
It's an image, but it's OCR.
And in addition, on top of it, to your question of this has to be understood by the domain-specific model that understands aerospace. The description came from that.
Okay.
Right? And this is just the beginning of the process that goes in, right? And he's just starting off with that. There's more to come. I'll stay around for his assistant.
All right. I'm just going to show another example here that it is interesting to understand as well. Another thing that, although it's explaining a graph, a chart might be very hard to explain if you get a general purpose model as well. So here you see this is this chart and generate summary explaining exactly what the graph is about. Also, not straightforward to do. It's very important if you're building domain expert knowledge. All of that, it is interconnected with the knowledge graph. So this is important. How can this be used? On a traditional matter, what enterprises are using? If you're, I'm gonna start with a table stakes example, right? Everybody has that, but I just wanna show how Articul8 does do things differently on here. So this would be a question that we put on the platform. I ran that yesterday to do the test, and we see that a normal question, we get an answer in about 30 seconds. That goes through all the knowledge graph. Obviously, it tells you each section of that answer belongs to what paper, where that came from. It tells you the citation. Normal answer chat capabilities. That's not all on what we do too. So we do what we call a detailed answer on our model mesh technology. And we did this before deep research was invented, but that now that's common called out there deep research, right? That was run in 2.3 minutes. That means we are transversing your graph, seeing all the unforeseen connections that you have about that topic and allowing the model mesh run that dynamically and make those decisions. And we actually show this here. This is the execution graph. Every single dot here is an action that was taken on this dynamic execution graph. For either from, for instance, guardrails, where is it safe to run, to I need to do search, and I need to break that down because this is too complex. I need to find documents. I need to do context relevancy. I'm going to show that in a second. So how much relevant is it actually? I found this connection, but is it really relevant for what I'm trying to do? That's not only pertinent on the question and answer type of interface, but any mission that you want to run on an agentic system, that's really important. And all of that.
So a question that typically people have is, okay, you have knowledge graphs from data that is static. You have new data that is coming in. This is not even new data. This is actions you're taking on the system that's creating its own graphs. That's execution graphs that have to be combined together with the data knowledge graph to answer any questions.
And now this is being added to the knowledge graph?
Everything is getting added to the knowledge graph. Every action that a user takes in the platform is part of the knowledge graph. Not just the user, agent, system, anything.
Whatever.
Yeah.
And finally, I just want to point that we have a task in domain-specific models that look into your answer and tell me how good this answer is, and like I said, how relevant that piece of content citation from that specific paper versus this one, how relevant they are, and that helps the user to understand how relevant it is, and the system to surface those to the top as well. Very important as well. These are more common scenarios. So now that we have this platform that can run autonomously agents, what else can we do, right? How can we achieve hyper-personalized outcomes? So one thing that we would like to do today is we would like to show you guys how you can build your own digital twin, something that can be your digital persona in the platform to do things, execute tasks based on your persona. The experience that we're going to do here live today is we're going to base on public information. But if you're an enterprise, you can bring all the data that you have privately and help build a digital twin for an employee, for a department, for something that you want
like
to
a
simulate.
factory digital twin, those sorts of things? I mean,
Yes.
Is that what we're talking about?
That's right. And also, like this can be as shallow as, okay, I'll just get your information from the public and then I'll start sounding like you, to actually having something that works like you, to expanding that depending on how much knowledge you give. And of course, obviously, it won't be accurate or perfect the first time you build it, but the more and more you give feedback, it gets better, right?
Can you share digital twins across a team or a group?
Yes, yes. And that's even more is coming, so let's just go ahead.
Right. In interest of time, I'm not gonna run this.
And we did get permission from Ryan.
Yes, we
Time for me to leave and go back to bed if you've got this going.
So this is all your information here, Ryan. Like I found your LinkedIn, but I also found your Twitter. I also found your private websites that you have information.
Nice.
Private relay.
Keep it clean.
Like everything is on the internet talking about you. This is internet information.
Yeah.
So it can be used to build your digital twin. It takes about 2 minutes to build. In the interest of time, I'm gonna jump.
Just go ahead and build. And then
I'm gonna jump. I'm gonna show you what can you do with a digital twin. So just a quick example here, like with your digital twin. Who are you? What are you most interested about?
Well, this will be interesting. It'll be interesting to you.
Let's see.
It's like having a live therapy session.
I know.
Let's see if we're
Oh, I should clarify
Wi-Fi
that
is
they
working.
did get permission from Ryan
that's
before
right.
doing this.
That's right. Yes.
right.
And like we want to make sure that this is only the beginning, right? Meaning once you build the twin, you can actually go in and teach it to be more like you, exactly what you're going to do. Right? That's the intent.
Then how do you refresh the data set as his corpus grows? How does the...
So we can have a schedule. For example, you can say every 30 days, go and refresh it. We can have a trigger that comes from the knowledge graph saying if new information becomes available on a particular topic, go in and update all of the downstream effects. You could do all sorts of things.
Now, this is pretty cool. We could keep here, but I want to, in interest of time again, I want to jump forward and say, we have a platform that can run thousands of concurrent calls, and we can simulate digital twins of multiple persona. So the next logic step for us is like, let's put a bunch of you guys here and ask something and see what you guys are gonna talk about it. So we ask permissions from both Ryan, Nick, and Dave. They all gave us permissions to build their digital persona here. So we're gonna select them here. There we go. We built them ahead of time. And now, let me see if I have that question. I don't, I have a question here that it is interest to us. So I'll read out loud as well. So what do you think about domain-specific models? Are they going to be needed for complex use cases, or general purpose LLMs are going to catch up? That's interest topic for a discussion, right? I select you guys. I put in that squad mode. I will explain as we are running what that means, right? So now we are autonomously run the same questions to all the agents. As you can hear on the main diagonal, that's happening live. As those answers are getting complete, I can focus in one so you guys see that this is running live. This is using your digital twin to answer that. Nick is creating that based on whatever persona was created. But also, after that is done, every other agent are going to opinionate it about the other agent answer.
There's a concern here, a security concern, stuff like that. You know, how do you lock down this capability so that somebody couldn't take and do
Absolutely. So that's why this is built with consent. It's inside locked enterprise environments, and this is not open to anybody going and building a digital twin or somebody else. However, if your information is out there,
it's public.
It's
public.
public.
We all have public information.
Public information, people can do that.
Information exhaust, so to speak.
But the next generation of it is, if somebody wants to officially use your digital twin, you have to attest it. And to the monetization question, if you can attest a digital twin and somebody is using it, you could potentially monetize it. That's really where it could go, right? Imagine.
Which is exactly what
Like virtual CTO.
Keith is already doing.
But here, the reason we did this is you can see the diagonal is the opinion of each of the experts. Cross diagonal is what they think about the other person's opinion. And then in that one round, here is the summary. And then no brainstorming session ends with one round. So the next round goes on. And at each round, some experts might change their opinion. Some experts might dig in. And the overall discussion can continue on. And the whole point is, when you want to get an actual nuanced answer from a group of experts, it's not just a question and an answer. You need to go through analysis. And the analysis also is fully auditable. And every expert who allowed their digital twin to be used can go in and say, you know what, that particular answer is wrong. I don't agree with it, change it. And you can rerun it. You can go back to it, right? And we have systems where once everything is complete, it'll give you the summaries. It'll tell you whether the discussion is converging or diverging. And if it's diverging, you can inject some other questions or topics to get it back to convergence. So all those things are possible. And our intent here is to get into enterprises to get outcomes. It's way more than just a question and answer chatbot, right? And in order to do this, I mean, imagine it's 9 calls going simultaneously, multiple things going in, and one has to wait for the other. All of these things have to work. In this case, it says it's actually converging. If we had time, we would inject a maverick who disagrees with everything that everybody says, and you'll see that the actual discussion diverges very quickly.
His name is Ray.
Thanks, Dave.
I love you, Ray.
So this is just an example, right, with public information. But if you're running this on your own enterprise, this is a multi-tenant system running in production on your own premises. You can control with fine-grained control who has access to what. You control who has access to your agent. You control who can talk with your agent on the API level as well. This is always controlled by you as you own that agent. So this is, no one can talk with your agent if you don't allow to.
And where this would go is also where AI slop has gone today, right? Which is anybody can build a digital twin of you, of course, in a general purpose system, but it'll only be as good as what you can potentially guess, right? And many times it'll actually give you misleading information. You walk into a situation like this where if I ask, are the 8 people here going to agree with me or disagree with me, I'm more or less going to get an average answer. No offense to any particular field, but if you go talk to an astrologer, you more or less get an answer that is on average. That's because on average, more or less sounds okay. That's really what you might end up getting. But if you want specifics, you need to go get an expert who attested their own digital twin. They should have trained it.
So could you plug this into like a Zoom call and stuff
Absolutely.
like that?
We've done
We've done that.
You know,
and
relatively, and provide a summary of what went on.
provide summaries, say, okay, these are going to be red flags, these are going to be okay meetings.
More briefings.
In fact, it all started with me doing an experiment where I had a BS meter running. And it basically went up and down, and I was initially watching it, and other people started watching it, but then it started out fun, but then you'll be amazed the BS score for meetings in some enterprises.
I think that's a must for y'all's next presentation.
Sum equals most.
And I just wanted to bring this up because you asked about observability and auditability in security. This is a very important concern for our enterprise customers. Although the actions are autonomous and dynamic, every single thing is observable. You can tap into and see, understand what was action that was taken. You can change the behavior, and you can have that set for yourself that will update the knowledge graph. All of that is observable. You can see everything that was done on your behalf, and you can see the details of it. We are doing a visualization here on that the flow, but you have on that
You're
on
sort
the
of
API.
hiding the whole agentic side of this thing. And behind, this is the outcome I'm looking for.
Yes.
It's
That's why this is actually hidden, but
if you wanna see it, it's
if you want to see it's there. This is all available on the API, so if you want to audit it, that's important. But let me see if that completed. Yes. So after it is done, and then it actually gives you a summary about all the discussion that happened between the digital twins, what they achieved, what they got in agreement, and also what are the action plans for you to do after that. So very important as well. And obviously, if you have that report, you can come and export that as a PowerPoint presentation, a PDF presentation that will come nicely formatted for you. You can use it as a report. So at least the AI slop here is a little bit better because you had digital twins actually debating about the content. It's not just a one-shot answer out there.